Thank you, Marcy, and thank you everyone for joining us. As Marcy mentioned, I'll be doing the first part of the presentation on BCD 130 2018 IBC by BC, and Sandra will be doing the second half. And as a bonus today, we have James Smith, who is the Midwest Regional Manager for American Wood Council, that is joining us and will be providing some commentary on the code changes. So that's a different format than what we've used in the past. Additionally, since this is a 2-hour presentation, we will be stopping midpoint between the IBC and the IRC to take some of the questions and answer some of the questions that you have in the question box. Okay. Now this presentation is registered with AIA for continuing education. Additionally, it's also registered with ICC and NCSEA. And then if you've downloaded a PDF of the presentation, you've received the course description, and I believe Brian is providing PDF links to the PDF if you haven't downloaded it already. And then we have the learning objectives for today's presentation. First learning objectives is becoming familiar with significant changes between the 2015 and the 2018 IBC for wood provisions. We also have be able to locate and analyze content within the 2018 IBC for the wood provisions. And for the third learning objective, we have familiarity with new IRC 2018 regarding wood use. And the fourth one is fire requirements, being able to explain and use fire protection requirements for wood within the IBC and the IRC. So once again, thank you for joining us, and I'll bring back Marcy, who will activate the first 2 polls.
Sure. So the first one is always easy. Just let us know who you are. Actually, not who you are, but what you do. Go ahead and vote. As always, I give about 30 seconds and or until about 80% have voted. So. Alrighty, I've got about 80% and 30 seconds exactly. All right, and let's share that. So we've got about 68% engineers, 19% code officials, 6% architect, 5% other, and 2% product manufacturers. So thank you all for being here. We're glad you're here. That gives us just a little indicator of who we have here and how we can tailor this toward you. We're going to move right on to another poll just to give us an idea of your familiarity with the IBC. How often do you use the International Building Code IBC? Do you use it every day? Do you use it periodically, or is it periodically that a project references the IBC? Have you just looked into it once or twice, or what is the IBC? So give us an idea of your familiarity.
What is the IBC?
All right, so we've had about 30 seconds. Let's close this and see how familiar you are. So everybody knows what the IBC is. That's great. 52% use it every day. 44% use it periodically, and 4% have looked in it once or twice. So I would say it looks like most everyone uses it pretty often. So.
Very good. Thank you, Marcy. We have a good feedback on what our makeup of our audience is, and mostly engineers. And although the changes related to wood construction is mostly related to fire protection and detailing requirements for balconies, et cetera, not so much structural requirements, but let's look at those. So we're going to start off with the 2018 IBC. And this is part one. This is a broad brush stroke to look at some of the major changes related to wood construction, covering exterior balconies, special inspection and special structure and structural observation, fire retardant treated wood, fire protection, heavy timber and mass timber construction. That's going to be very, very interesting in the coming codes, especially now also this year, and then construction type. So this presentation is organized such that we work our way through the building code starting from chapter 2 on down. I bring this to your attention because this is a helpful table in that some sections in the code have been relocated from one area of the code to a different area of code. And we often get questions like, where is this within the code? It's not there anymore. So in every edition of the building code, at the beginning of the building code, there are these helpful tables that tell you where something was previously located and where something is located now. And I bring this to the attention because the bulk of the changes that occurred in the location have to do with balconies, which is here in chapter 7 now, which used to be in chapter 14. And then a lot of the changes related to heavy timber construction that was in chapter 6 have moved to 23. So it'll tell you exactly where it's been moved. Now, the first change that we're going to talk about is in chapter 2, which is the chapter on definitions, and it has to do with approved agencies. Now, the definition for approved agencies includes agencies that conduct tests or furnishing inspection services. New to the 2018 IBC is the inclusion of product certification report writing agencies. Now, all of these are related to are approved agencies, but one thing to note is all of these need to be approved by the building official. On to chapter 6. This is chapter 6 is types of construction, and we have 5 types of construction that are included in the IBC. This particular slide deals with 602.3, which is type 3 construction, and 602.4, which is type 4 construction or heavy timber construction. So there's been a clarification within this section related to the exterior walls. Now in type 3 and type 4 construction have exterior walls of non-combustible material, and it permits fire retardant treated wood within the exterior wall assembly of assemblies that have 2-hour fire resistance or less. Now in the code is a clarification of what wood framing really means. And I'll let Jim provide some background behind this. And I'm not
Thanks, Michelle. Yeah.
There you go.
Nope. Can you hear me?
Yes.
Yeah. Thanks, Michelle. The one of the things relative to the sheathing itself is a lot of code officials were misinterpreting the concept of what framing meant. So you know, they would refer to that and they would say, well, that only means the 2x, wouldn't include any of the other structural elements, which in a lot of cases is the sheathing of the exterior wall. So that's just a clarification what had been intended all along. I also wanted to take this opportunity to point out that you know, it's worth noting that the reference to the minimum 6-inch thickness remains, even though AWC proposal G184-15 was approved as submitted, and that deleted the reference to a 6-inch minimum thickness. Another AWC proposal, G179-15, was on a different topic that retained the 6-inch minimum provision when being when being correlated. The change that was approved as G184 was lost. We're going to be moving forward a proposal in this next cycle. So if you're in Columbus, you'll be watching for that to basically correct that correlation issue, to make sure that the 6-inch isn't a critical item. As you can imagine, when you're dealing with an exterior wall that has to have a fire resistance rating, it's the thickness that's required of the fire resistance assembly that's more important. Thanks.
Great, good feedback. providing background on the code changes. Okay, let's progress. Let me go. Okay, the next provision that has some clarification is Chapter 7, which is fire and smoke protection features. And this specifically has to do with fire resistance rating of structural members and specific to column protection. There's been a clarification in that what it states is that column protection states that columns shall be provided individual encasement protection by protecting it on all sides for full column height. However, there is an exception to this for light frame construction, in that the exception has been modified for studs, columns, and boundary elements that are integral elements in walls. In other words, in light frame construction, where the primary structural framing member requires fire resistance protections, the columns need to extend between the top and bottom plates, which is shown here. Then the membrane can provide the proper fire protection. And here's a plan view of such an assembly, a 1-hour fire resistance assembly with a column that lands within it and an integral part of that wall. So let's bring Jim back, who will provide some more background on this.
Yeah, thanks, Michelle. This was AWC proposal FS7 in the 15 changes. We were compelled to propose this after learning that some jurisdictions, some of the code officials, had been incorrectly interpreting that those construction boundary elements, such as these built up and solid wood elements, are by definition, again, going back to the definition, of columns, and wrongly requiring them to be provided with individual fire protection, like columns that are part of the primary frame. The modifications included in the proposal clarifies the correct intent of the provision. It's been verified by ICC staff that it was never the intent to require individual protection of those types of structural elements, even in meeting the definition of a column. So as they're not considered a portion of the primary frame. Thanks.
Great, thanks, Jim. This next session has to do with the extent of projections. And this is not just for wood construction, it's just any material of construction. And as you can see, here's a building and we have a lot line. Between the lot line and the building, we have something that's called a fire separation distance. Now, in this particular building, we have some overhangs, and there's a minimum distance that is required between the overhang and this lot line. This provision, or more of a modification of the provisions, was modified to be more in line with the 2012 IBC, but it's drastically reduced from the requirements that were shown in the 2015 IBC. And this shows you right here that this last row shows that the distance, the fire separation distance, has been reduced to 5 or greater feet, and the distance required, the minimum distance from that edge of the roof to the line, lot line, is 40 inches. So going back to the previous slide, the distance here is now, the parameters is 5 or greater feet. And then the distance from the lot line to that projection went from 20 feet to now 40 inches. So this is pretty big, substantial decrease in that distance. Go to the next slide. This provision has to do specifically with combustible balconies, projections, and bay windows, in that it was relocated or located to Chapter 7. So it used to be in Chapter 14 under combustible materials of exterior side and exterior walls, and then just been relocated to Chapter 7 in the fire protection chapters. That's the only clarification here, a relocation of this section. And also the inclusion of plastic composites are now permitted to be installed in as guardrails where untreated wood was allowed. And we're still in chapter 7 under section 706. 706 is related to firewalls. And this is something that has come into play related to the structural stability of the firewalls. Now, if the firewalls enable a building to drastically increase the size of the building, provide more allowable square footage, and the firewalls provide each portion of the building protection should there be a fire on one side of this wall. So it's treating it as if it's two separate buildings. Now, under the 2015 IBC, there was there needs to be total separation between the two firewalls. Under the 2018 code, however, this has been clarified and modified to allow for the diaphragm to continue through. Now, what you imagine, if you look at this building under an earthquake, what happens is the building wants to shake. So we can either do two things. We can either provide a seismic separation between the two buildings so that they don't bang into each other during an earthquake, or we need to connect the building together. And if we had to provide a seismic separation, this separation could be really big and something that's not architecturally pleasing. Sometimes there gets some detailing requirements that's not always something that can be provided in this type of architecture. But by connecting the two, now the buildings act together in an earthquake. So under the 2018, we now are allowed to provide continuous diaphragm through the walls, and this applies to seismic design category D, E, and F. And this allows that continuous diaphragms, and the maximum thickness of that diaphragms is 3/4 of an inch. So seismic design category D, E, and F, and maximum sheathing, roof or floor sheathing is 3/4 of an inch. Now this provision came about from CIOSC. This is a white paper that was provided. So for some of you that are still on the 2012 or the 2015 IBC and you would like to have this continuous load path in your buildings, this is a supporting document of the code change, and it's a seismic related to seismic, CIOSC Light Frame Construction Committee from the Structural Engineers Association of Southern California with a seismology opinion that's stating that even in high seismic zones, it's important for that diaphragm to be continuous. Also noted on this slide is a graphic or I think it's Revit or some other drawings that can be downloaded from the Woodworks website that shows a detail of a 2-hour fire rated wall at the floor. So some helpful tips for you looking out for information related to this. Okay, this provision is, now we're going into chapter 8. Chapter 8 is on interior finishes, and this particular section is 803 on wall and ceiling finishes. This is a clarification related to interior walls and ceiling finish materials. They need to be classified for fire performance and smoke development per the code criteria. And the only change here is that the criteria has been just reorganized. It's all the same criteria, it's just been reorganized. Now, the interior finish requirements is for any material used as interior finish, trim, and decorative materials, except for heavy timber elements under the 2015 code, but there's been an exception now made under the 2018 code. So I'm going to bring in Jim again, and he's going to provide a little bit more commentary related to this.
Yeah, thanks, Michelle. AWC was the proponent of this code change. That was FS 132-15-15. For quite some time, the regional managers, the folks in the that are providing assistance with, or actually providing some thoughts, kind of linked to the code officials for AWC. We felt that it was not appropriate, and we had felt this way for quite some time. We felt that it was not appropriate for heavy timber elements to be exempt from the interior finish requirements of the exit enclosures. It's just that exception has been in the code for a long time. But again, we just felt it wasn't appropriate. So for exit ramps, exit stairways, exit passageways, those exit enclosures, you now have to have even the heavy timber elements comply with the interior finish requirements. It may have been justified when only a small portion of the walls or ceilings were heavy timber, think beams and columns. But with CLT coming into the market more and more, we felt that it was more important to make sure that the interiors of those exit enclosures met the interior finish requirement of the code. Thanks.
Great, good background, great background. Okay, and then still in section 803, wall and ceiling finishes. Now we have a section 803.11 related to laminated products factory produced with wood substrates, and then facings or wood veneers intended to be applied on site over wood substrates. There's been addition to the code now that provides some criteria for testing of these type of elements with related to their fire resistance. And now we're into chapter 16, which is the structural design chapter. And under section 1607, live loads, there's been a modification to the requirement for the design live load. In the previous 2015 IBC, the design live load was the same as occupants served. So in other words, if this was a residential, the residential floor may be designed for is designed for 40 pounds per square feet. And so the balcony could be designed for that same occupancy served. Now, under the 2018, we have a criteria of 1.5 times the room live load and not less than 100 pounds per square foot. So this applies to decks and balconies. And now we're traveling into other areas of the country where we may have some risks of tsunami loads. And there are many coastal communities in the Western United States and on islands in the Pacific Ocean, which need tsunami resistance design for critical structures and essential facilities. So there's a new section, 1615, for tsunami loads needed to address for design of these areas, and risk category 3 and 4 structures. And for structural observations, now we're into chapter 17, which actually is titled Special Inspections and Tests that include structural observations. And what we see here now is there's a general section, 1704.6, that covers structural observation in general. And we've see some clarifications in the 2018 code where they've clarified and consolidated what was common to both seismic and wind structural observations and tucked it under the structural observations general section. So that was a clarification and a consolidation. Also, there's been a clarification related to the wind design speeds of changing from 110 miles per hour to 130 miles per hour for risk category 3 and 4. And this is the trigger for structural observation. Now, this change is now aligned with when we were doing designs in allowable stress design. You recall the wind speeds went from 110 to 130 miles per hour. So this is to align with that change from going from allowable stress design to an LRFD design. Okay, now we're also in the same section, chapter 17, related specifically to special inspection of wood construction. So periodic special inspection is required for nailing, bolting, anchoring of fasteners, etc., of the main wind force resisting systems. And this includes shear walls, wood diaphragms, etc. There's an exception to requiring special inspection that has been clarified in that it's based on a specified fastener spacing at the panel edges of more than 4 inches on center. So in other words, special inspection is not required if you have spacing greater than 4 inches on center. What was clarified is, one, they now say specified fasteners, and it used to say fastener spacing of sheathing, instead of, now it says at panel edges. So specifically stating the panel edges, because you can have different spacing of your nails at panel edges versus your field nailing. So now specifically to the panel edge spacing. Okay, so let's bring in Marcy for a poll.
Yeah, so which of the following is not true for floor sheathing at light frame double firewalls? That it may be 1 inch thick, that it may be continuous through firewalls in SDC E through F, that it may be continuous through firewalls in high wind zones and SDC D, or answers B and C. So go ahead and answer. And we've got about 30 seconds, but only 40% voted. So I'm going to give it a little longer here. This seems like a question that may need a little more thought.
Yeah, it was a little tricky. Since we've gotten complaints that ours are too easy.
Yeah, and anytime there's a question with a not in it, always have to do some mind bending. I'm going to go ahead and close it though, because we've got 80%. So, all right, so 56% say it may not, or it may be 1 inch thick. 30% say both answers B and C, that it should be continuous through firewalls in SDC E through F, and that it can be continuous through firewalls in high wind zones and SDC D. All right, so Michelle.
All right. So this was a little bit tricky because we said what is not true, but it looks like the majority of the audience did get the correct answer because, one, the maximum thickness of the sheathing is 3/4 of an inch. And the provisions are for seismic design category D, E, and F. And so answer B is correct because that includes E and F. And even though we talked about high wind zone, if it's in seismic design category D, it still covers that seismic design category because it's D, E, and F. All right, great, thank you. Right answer. Okay, now we're on to chapter 23, which is wood. We have some reference standards that have been updated to the most current reference standards. Right here, you'll see that it's also noted in chapter 23 of the IBC as well as in chapter 35. And we have an updated 2018 NDS and a 2018 wood frame construction manual. And you should note that although the title says wood frame construction manual for 1 and 2 family dwellings, there is some provisions within the IBC to allow it for actually all occupancies, provided it meets the criteria or the limitations of the wood frame construction manual and those listed in the IBC. So we've expanded the scope of the use of this document I believe that happened in the 2015 IBC. And also we have an ANSI 117-2015, the standard specifications for structural glued laminated timber of softwood species. Now all of these standards are design standards. And the reason why I point this out is, one, that on the next slide, we also have a standard related to structural glue laminated timber. And this is a manufacturing standard, whereas the previous slide, and I'll go back to that, contains information for design of structural glue laminated timber members. And again, this one, the structural glue laminated timber standard, is for the manufacturing and quality control of structural glue laminated timber. And that's really what all these other standards are related to, the manufacturing and quality control of these members. The PGR 320-217 is related to cross-laminated timber, and then we have standard for performance-rated engineered wood siding, and I'm not sure what happened to that NG, and then also for the engineered wood rim. So all of these have been updated. Oh, the one thing I should note is back on this slide related to the design of wood structures, the NDS and the wood frame construction manual have been updated, but the wind and seismic provision of 2015 edition still remains. That has not been updated. That will probably be updated in the next code cycle. So no changes there related to the wind and seismic provisions. And now further into chapter 23 related to fire retardant treated wood. This is under the section of minimum standards and quality. And 2303.2 is the fire retardant treated wood and defining what fire retardant treated wood, which is any wood product that when impregnated with chemicals by a pressure process or other means during manufacturing. Now, this other means during manufacturing is where we have some modifications and clarifications. So the approved modifications clarified that other means during manufacturing was not intended to permit surface protected products as outright replacements for fire retardant treated wood. And that's given the requirement for chemical, impregnation into the wood. So clarification that the definition of other means during manufacture does not include paints, coatings, stains, and other surface treatments. Now, this was not to not allow these type of treatments, because there is a path to allow this into wood construction, and that's through section 104.11 of the code, where it can be evaluated and approved using those provisions. Okay, nail laminated timber or mechanically laminated timber. This type of construction is becoming more and more popular as part of being mass timber construction. It's actually been in the code since the early 60s, under IBC at least. But what we see is in addition to the requirements for mechanically laminated decking. Now, this is under the section of 2304, General Construction Requirements for Lumber Decking. And I'll bring Jim in to provide some commentary on this provision.
Thanks, Michelle. Basically, what we're trying to provide is a little bit of information to help folks understand the acceptability of nail laminated timber, and more than anything else, to recognize that there are other types of products that are out there that are commonly used with power-driven nailers. So we've included some tables that'll provide those equivalencies to the 20 penny nail that had been pretty much the standard since, as Rochelle noted, those provisions were included in the UBC, they were included in the NBC. I'm from Wisconsin. The Wisconsin Commercial Building Code had nail laminating provisions like this, the 20 penny nail provision, since about 1956, if my memory is correct. Thanks.
Okay. Thank you, Jim. And for those not familiar with nail laminated timber, this is just an animation to show you. These are buildings that or a building that was built actually in California. And nail laminated timber is actually 2-bys that are set on edge, which is shown here. What is not shown in these animations is the actual fasteners that are prescribed within the code. The last few show it, but it just gives you an idea of how these are constructed with solidly built floor systems using nail laminated timber. Okay, and then as was mentioned previously, a new table is now included to provide fastener schedule for mechanically laminated timber for 2x members that will be helpful for those looking for some spacing requirements and fastener requirements. Okay, now further into the chapter 23, we have roof sheathing requirements now related to general construction requirements. If most of you are familiar with the IBC, there's a fastener schedule in table 2304.10.1 that has been modified to include, now we have 8-penny and ring shank nails that are addressed now in this table when the nails are required to be at 6 inches on center or 12 inches on center. And this was included to more align with, have an alignment between the IBC and the IRC, as well as to meet the requirements related to wind uplift on the roof sheathing. And we'll mention this more in the next slide. Now, the NDS, 2018 NDS, has been referenced in the IBC, and there was some one of the major changes that have occurred in the 2018 NDS, as well as the wood frame construction manual, has to do with the significant increase in components and cladding roof wind pressures per ASCE 716. The wind uplift related changes include fastener withdrawal and new fastener head pull-through design provisions. And thus the inclusion of roof sheathing ring shank nails that are allowed, deformed shank nails that are allowed now, or provided provisions within the NDS. We have a webinar that is recorded on our website that gives you more in-depth information, and it also provides some design examples on calculating the withdrawal values for nails to resist these increased wind design provisions. And that I have a link in the presentation that can get you to the actual webinar e-course on our website. Okay, heavy timber construction. Now this is, I mentioned in the beginning of the presentation, where there was some provisions that were in Chapter 6 of the code, type of constructions, and was relocated or is relocated to Chapter 23 and has been reorganized. And I'll bring in Jim to provide some more background related to this change or reorganization.
Thanks, Michelle. This is what you're seeing up there is the table for member sizes for heavy timber elements that were moved from Chapter 6 as a part of our AWC proposal G179-15. G179-15 was an extensive proposal that moved all the heavy timber size minimums from Chapter 6 to Chapter 23. The reason was so folks would not confuse mass or heavy timber size structural elements with a type of construction, i.e. type 4, commonly referred to as heavy timber construction. The proposal included a number of other changes, 602.4, table 602.4, all the way up to provisions that are included and shown herein. But some are created, and it basically created the new 2304.11.42, and primarily for the purpose to help folks when they're working with the code to differentiate heavy timber as a type of construction versus what is a minimally sized heavy timber element. Thanks.
Great, thank you. Okay, I'm trying to shift some of these things around. Okay, next section. Now we're getting into balconies and decks and or elevated walking surfaces. There are many areas around the country where there are numerous examples of wood construction with balconies. And this has to do with permeable floors and moisture barrier in wood construction that we see some additions to the code to help mitigate with some challenges that one might see. The first change has to do with providing detailed construction details in the construction documents, as well as inspection for impervious moisture barriers when used for exterior balconies. And this occurs in Chapter 1, which is the scope, in the IBC, as well as the IEBC, which is the International Existing Building Code. And what this has to do is, if we have wood construction shown here, there are some designs that may have a permeable floor, maybe concrete, or maybe there's some tile or whatever. And between the permeable floor, there is a moisture barrier to protect the wood construction. And I'll bring in Jim one more time to provide a little background related to this.
Thanks, Michelle. This was AWC proposal S279-16. That was proposed in response to the causes associated with some of the deck and balcony failures that had been taking place. Essentially, this creates a requirement for the installation of an impervious moisture barrier system between a permeable floor system that's exposed to the water and the wood structure below. It also requires a mechanism for the water to drain out. So in addition to the provisions that Michelle referred to earlier in the administrative section, to make sure that there's some follow-up, some inspection, to make sure that these provisions are in place, this provides you with the actual technical requirements. Thanks.
Great, thank you. And so the new provisions include, as Jim mentioned, details on the construction documents, special inspection, and positive drainage of water, as well as ventilation in the below the floor or roof to protect the supporting wood construction. And then now we're continuing into Chapter 23 on wood and the conventional light frame construction. This is specific for headers and girder spans at exterior walls, where we see a modification that includes now an update for allowing Southern Pine grade number 2. Before it was Southern Pine number 1, and so we've now expanded the use of wood construction by allowing number 2. And so as a side note, the IRC and the IBC have been different since 2000 IRC and IBC, as well as 2001 wood frame construction manual. So this is aligning their tables, plus there's some differences in load equations over the last 2 decades that have changed the length of the header spans. But this specific provision generally shortens the span, and it also takes into account, the Southern Pine number 2. One other thing that it takes into account is to align with the wood frame construction manual also is, well, here on footnote B, this strikes out number 1, Southern Pine. But in footnote F, note that the spans are calculated assuming that the top header and girder are laterally braced by perpendicular framing. So this may shorten what if you have dropped headers, for example, where you have cripple studs above, that's not providing that lateral bracing. The spans that are located in the table will need to be reduced. And it says for 2x8 or 2x10 and 2x12, they should be multiplied by 0.7 for the girder and header sizes. And so there's a 30% reduction if the actual header is dropped. And similarly, similar changes for the interior walls as well in the conventional light frame construction section. Now, because we are becoming more and more conscientious about the actual energy requirements that are needed within our environment and the buildings that we built, now the IBC reflects allowing the allowance of more insulation within the walls. And this is reflected, in the provision for headers, now permits a single header under 2308 And these are typically spans of 2 to 4 feet, but this allows for additional insulation in this cavity with a single header. Now on to the last section of this part of the presentation, and it's on ASCE 716, which may cause, when you look at the provisions of ASCE 716 and the IBC, there may be some confusion by designers and code officials. And so this part of the presentation is to provide you with some background from some changes that were defeated, which specifically are noted here, and it give you some background to provide a conversation with you and the code official related to some of the changes. Here, with the things that do align with the IBC is ASCE 7 is referenced in Chapter 35 as general reference in Chapter 35. And the IBC wind and seismic load provisions agree with the update in criteria for ASCE 716, as does Chapter 18 seismic provisions in accordance with ASCE 716. So all of these are now aligned. However, when we get to the snow provisions, determining the snow loads, there may be some challenges. A proposal to update IBC snow load provisions to agree with the updated criteria of ASCE 716 was defeated during online voting. So now the IBC allows 3 paths rather than 1 for determining the snow loads. We have the IBC determining snow loads based on the figures and tables within the code. We have a new ASCE 7 for the Western US and New Hampshire that has a specific table for those areas. And then the third path is the reference state-produced maps, which have a greater detail for the Western US and New Hampshire. So 3 paths. You'll have to work with your code official to see which one is acceptable. Maybe all 3 is, and you can determine that with the code official and design appropriately. Another area where there is some disconnect between the IBC and the ASCE 7 has to do with roof drainage and determining the rain loads. There's a requirement for secondary drain loads, but the criteria is different between the IBC and ASCE 7. ASCE 7 bases their minimum requirements on 15 minutes and a 100-year event, whereas the IBC still uses the 1 hour, 100-year event for both primary and secondary minimum loads. So this is something that was proposed to remove to be alignment in the criteria, but it was defeated in the online voting. So more reason to get involved with this. So now let's bring in Marcy to talk about the 4th poll.
Yes, indeed. So exterior balconies with an impervious moisture barrier system over wood structure supporting moisture permeable floors shall have A, positive draining of water, B, ventilation below the floor system, C, details in construction documents, D, inspections for impervious moisture barriers, or E, all of the above. Right. So we have about 50% have voted. People are pretty consistently voting, but let's keep going. And I've got about 75% that's just kind of hanging out there, so I'm going to go ahead and close. And so we've got 88% say all of the above, 9% A, positive draining of water, and just 1% in all the others. So I'm going to go ahead and give it back to you, Michelle, and you're going to give us the real answer, please.
Okay. Are you back to me? Okay, the real answer is all the above. So there was requirement for positive drainage of water, ventilation below the floor system or roof system, details in construction documents, and inspection for impervious moisture barriers. All of that is included within the provisions now. Okay, great. So as some resources, there is a Structure Magazine article that was co-authored by Buddy Showalter, Dave Tyree, and Sandra Hyde, our guest speaker. And it provides the overview of the significant changes related to wood construction in the IBC as well as the IEBC. The IEBC just is related to the balconies and the detailings related to the permeable construction of floor systems and the moisture barrier. And one thing is different related to this new article, if you're familiar with our articles in the past, is now we provide the code change, which is noted in red, if you can see this right here. And it relates to sorry, at the end of the actual article, we have these appendix, which lists the actual code changes that occurred and gives you the language from those code changes. So this is a little bit different and provides some helpful information and background related to the specific code changes. And I think Brian can provide you with a link to this actual article, a PDF of this article. Also within this article is this really helpful article on Insight All Decked Out related to detailing requirements and the provisions of balconies and wood construction that has a lot of helpful details related to the requirements of these type of construction. And I believe Brian also has that link that he can send you. Now, if you missed our webinars in the past, we do have a webinar on the NDS 2018 NDS and the 2018 Wood Frame Construction Manual. These are both available. The publications are available on our website for free. It does not include the commentary, and it's a read-only version of the PDF version of these publications. And here's the actual webinars that are available, and you can earn ICC credit, continuing education credit, by watching these webinars, as well as AIA. And there's some other resources related to the IBC that ICC has available, which is the significant changes to the International Building Code. I believe only the hard copy is available now, as well as significant changes to the provisions of 716, ASCE 716 that's available. So right now, we'll take a little break and answer some questions that have come in. And I don't have...
So Michelle, if you could go back to slide 22, we did have a few questions about deck live loads that came in, and I've kind of given Sandra a heads up on this question. So Sandra, if you could unmute yourself as we get 22? Back there. Yep, on the live loads. Yep, that's it. So there was, I think, a little bit of confusion about what was said versus what shows up on the slide. So Sandra, perhaps you could clarify that, since Michelle's not probably seen these questions since she's been teaching.
Yeah. So with deck live load, this provision is matching ASCE 7. So ASCE 710 and 716 both have a requirement that you're going to do 1.5 times the room that is attached, that is connecting to that deck's live load. But it is capped at 100 pounds per square foot for both the IBC and for ASCE 7, because that's an assembly occupancy. And at that point, the number of people in a room is quite high, so you're allowed to have a very dense population in there, same as the deck, and therefore they cap it at that 100. As far as the IRC goes, if you're also interested there, it did not change. So the IRC still has the 40 PSF limit and is not connected to the IBC and ASCE 7.
Great, great. Perfect. I think that clarifies for a lot of the questions that came in. Next one, Michelle's up on slide 17, just a couple slides earlier, where we talked about the structural continuity between firewalls, and folks were wondering about SDC A through C. Is it applicable there? And follow-up question, why the max requirement for panel thickness? And this has to do with, the collapse requirements. So I guess the first question, what do we do with SDC, seismic design categories A through C?
In seismic design category A through C, we're not allowed to have the sheathing go through the firewall. And let me back up a little bit, because this is 706.2, structural stability. And what it states is firewalls shall be designed and constructed to allow collapse of the structure on either side without collapse of the wall under fire conditions. And that is one reason why the wood structural panel is not allowed to go through, because we want to have this wood, this side of the building, or I'm going on the wrong screen, this side of the building, to be able to collapse if there's a fire and not pull this side of the structure down. And
this is Jim. I think what, and you're making the point is exactly what was intended. The reason that they capped it at the 3/4 inch was to take into consideration that, if you had a 3-inch type of sheathing going through there for diaphragm provisions, the probability or the potential for that type of a failure during fire to have 3 inches of solid material going through the firewall might actually start impairing the building on the other side. Whereas the feeling was at 3/4 inch thickness, if you had a fire that was causing the failure, the probability of any material remaining after a substantial fire, and when I say material remaining is what would be left of the 3/4 inch sheathing, should not be significant enough to pull down the other side when it finally did fall away. It's gone. So that's why the maximum 3/4 inch was provided.
Okay.
Good feedback.
All right. Well, those were the two main questions that came in. So I think we'll go ahead and jump to Sandra's part of the presentation, if that's the plan, and then we'll still deal with more Q&A toward the end.
Yep, that is the plan. And let me switch to her. And I'm trying to, okay.
Thank you, Michelle. So we're going to continue on with the 2018 IRC significant changes. And as a reminder for those of you who don't look at the IRC very often, the IRC focuses on single-family dwellings, two-family, so duplexes, and townhouses. So with the IRC, we're looking at changes to the updated reference standards, fasteners and framing changes, fire resistance, decks, wall coverings, and roofs. And you will see that some of these changes mirror what has happened in the IBC. So first, a polling question with Marcy.
Absolutely. And here we go again with a similar one. How often do you use the International Residential Code, IRC? Again, every day, periodically, a project references the IRC. You've looked at it once or twice. And what exactly is the IRC? So, no shame. Just let us know what your familiarity is with the IRC. So I've got about 76% have voted and 36 seconds. So I'm going to go ahead and close. All right, so 46% have periodically referred to the IRC, 29% every day, 22% have looked in it once or twice, and just a couple percent are totally unfamiliar. So it's a little less prevalent than the IBC, but still mostly people are pretty familiar. All right, back to you.
Okay, thank you. Okay, that was sort of what I thought would happen since we have primarily engineers. So looking at the IRC, we'll be looking at things that are changes, and then I'll try to also explain for those of you unfamiliar with it why that change is happening. So the first items we're looking at are updating the reference standards, and we'll see here that this exactly mirrors what happened within the IBC. So the 2018 NDS and 2018 Wood Frame Construction Manual are both referenced in the IRC as options to use for the design of the wood structure rather than using the IRC. The standard specification for structural glue laminated timber is unusual only in that for those who are architects or building officials, you're accustomed to looking at A117, which is the same number but happens to be for accessibility. And we actually have a standard that comes from an entirely different group with that same number. So just a little strange to see. The manufacturing standards are identical with the same addition referenced as the IBC. So we once again have updates for glue lam, for cross-laminated timber, for engineered wood siding, and wood rim boards. The approved agencies, that whole approval concept, as Michelle mentioned, is that a building department pre-approves a group for whatever function they are providing. So whether it's a testing agency, a special inspection agency, or a group that provides product certification that's a third party to a manufacturer checking on those products, all of them can be pre-approved by the building department, and therefore the whole process of that approval happens more quickly. And that's the intent here. All right, so as we move into fasteners and framing, we're going to be looking at ring shank nails, at 12-foot tall walls, at headers, and at ceiling joists. So for our fastening schedule, there were only a few updates this round, and for those of you who aren't familiar with conventional wood construction in the IBC or the IRC, what we've had happening the last couple code cycles is that the description of nails has become more precise, and as we've merged the information in the IRC and the IBC, we actually have more options for those nails. So for item 13 of the list, we had a change in that double top plate splices were back in the wall bracing section for high seismic splices. They have been moved over into the general fastening table here. And you have options of your 8/16D common nails or your 12/16D box or 12/10D box or the 12 3-inch nails. Notice that each nail is being called out for its minimum length and its minimum diameter. And of course, if you're on a job site these days, nobody is hand nailing these nails. They're all power-driven nails. Each manufacturer goes ahead and does testing to make sure that their nail is equivalent to whichever nail they choose to do. So they may be providing a nail that is equivalent to the 10D box, and it may be a minimum of 0.128 inches by 3/8 inches long, or they can choose to test their nail and have a narrower nail, but they will tell you within the packaging that it is equivalent to this 10D box or whatever it happens to be. For the top plate splicing, same as previously in Chapter 6, you've got the face nails that are on each side of the end joint with a minimum 24-inch lap splice length on each side of that joint. The other change was to item 23, bringing in blocking as well as bridging to the joists. So you now have that option of using this nailing for either bridging or blocking between the joists. And here you've got the 10D box, which before it just had 10D without a reference to whether it was box or common. So this clarifies the size of the nail as the minimum size. There's also the two 8D commons or two 3-inch by 0.131 inch nails. These nails are going to be toe nailed in at each end of that bridging or blocking. In the roofing section, we also have addition, just like in the IBC, of ring shank nails. So we see an addition for our sheathing thickness table of the RS01 nails. And if we look at the footnotes, there's a little clarification occurring there. Footnote J is just adding that ring shank nail, stating what specification it needs to make, and that's a manufacturing specification again. But also in footnote F, we have for wood structural panel roof sheathing, notice where it says attached to gable end roof framing and to intermediate supports. With the 2015, we were just saying that this sheathing at the gable end was special. We needed to have more focus on it in high wind regions. And now we're saying not only that sheathing attached to the gable end roof framing, but to the intermediate supports as well. Where the sheathing is within 48 inches of the roof edge, nails are going to be spaced at 6 inches on center when we have our typical wind speeds across the country. But in those regions, in hurricane-prone regions and Alaska and a few places in Hawaii, you're going to actually bring the spacing of the nails tighter to 4 inches on center rather than the typical 6 inches that you'll see nearly everywhere else within the IRC. So most of that was not a change. It's just the intermediate supports that are the change this time. And there again, we have just sort of showing where the text looked like previously to what the text looks like now. It was a clarification of it. And just to try to emphasize that 4 inches on center occurring. Many people didn't even know that this provision was hidden in the fastening schedule table. So hopefully now that's a little more clear, and it shows that you need to go back 4 feet in that tighter nail spacing. Okay, the next polling question with Marcy.
Absolutely. So here we go. Can wood stud walls be 12 feet tall using the IRC? Yes, the wall bracing section allows walls up to 12 feet tall. No, the maximum story height is 11 feet 7 inches. No, a wall 12 feet tall requires engineering, or all of the above. So I've got about 60% voted and 40 seconds. So I'm going to go ahead and close. And then, so we've got 56% say yes, the wall bracing section allows walls up to 12 feet. 25% say no, it would require engineering. 13% say all of the above, and 6% say no, maximum story height is 11 feet 7 inches. Sandra, I'm going to let you.
Okay, so this question is in here because this section of the code has become somewhat of a mess in the last 2 code cycles. Through 2009, it was fairly clear because the statements weren't inconsistent. But in 2009, we actually changed to where you could have up to 12-foot tall studs in the wall bracing section. And at that point, we didn't have anything saying that you couldn't increase the story height. It was a gray area, not stated. So 2012, 2015, we have had tweaks each code cycle in the story height section saying, hey, wait a minute, you only can go up to 11 feet 7 inches for your story height. Great, except we can allow up to 12 feet tall for the studs, not the story height, but just the studs, and then need to add on that floor container for the total story height back in the wall bracing section. Well, those two are completely inconsistent. And with the 2018, we have a new table that addresses studs that are up to 12 feet tall for gravity loads and out-of-plane wind loads, which have been very poorly addressed in the IRC so far. So we're now trying to address this inconsistency. But even with the 2018, we still have that requirement that a story height can only be 11 feet 7 inches. So if we look through the IRC and try to figure out, okay, I've got a building that has 11-foot tall studs in my first floor, is that going to have to be engineered or not? It remains today a gray area, and we're going to go through where you can at least say no. If the building is in a location that meets certain requirements, you can use some tables to show that you do not need to have engineering there. And we'll talk about where those limits are and what happens if the building doesn't qualify. So the first new table trying to address this is table R602.3, parentheses 6. It's called alternate wood bearing walls stud size, height, and spacing, and is just trying to address 11-foot tall and 12-foot tall studs for gravity loads and out-of-plane wind loads. And the intent here was to look at studs that were in lower wind regions, in higher wind regions, high and low snow loads, wind exposure categories, and try to put a box around, okay, when is it okay to use a 2x4 stud? When is it okay to use a 2x6 stud in these taller walls? And what goes outside the limits here? So brand new table. This is the first time they're doing it. And you would think this would be a very simple thing because, you know, it's just a table that looks at 11 and 12-foot studs. And instead, it's just trying to fix something that was not clear already. So their limits were a snow load of 30 PSF or less. So if I am in the southern half of the United States, then I can use this table. If I'm in the northern half of the United States, I might be able to use the table. And if I am in an area with a snow load of, say, 35 PSF, then I am back in that gray area where wall bracing allows me to have the taller studs, but the story height section of Chapter 3 basically tells me for my gravity loads, now I need engineering, which is very different than anything else we've had in the IRC. So at this point, we can say if you want to have 11-foot tall studs and you happen to have a snow load of, say, 25 PSF, and you happen to be in an urban or suburban area with a wind exposure of B, then I can go onto the table if my wind speeds are 115 miles per hour and my floor span is 24 feet or 22 feet. I can look across here, say, all right, I've got 2 stories, so I'm roofing 1 floor. My studs are 16 inches on center, and looking at the table, if I use 2x6 studs, I don't have to do any engineering for my gravity or my out-of-plane loads. I'm just good to go. So that's the intent of the table, is to try to fix that hole that we've had going on. Now, at the bottom of the table are 3 footnotes, and in your PDF, these are broken down into more easily read statements Here I've put them together so you can see what the entire footnote actually looks like. So the first footnote talks about wall studs that are less than or equal to 16 inches on center. And if we go back, we find that the table itself talks about studs that are 12 inches on center, 16, and 24, which means the footnote doesn't address 24-inch on center studs. So that's, again, a gray area that we have that doesn't really say, okay, what's my minimum sheathing need to be? And so you need to go to other sections of the code, like section 602.3 parentheses 3, that is referenced in wall bracing, that has a minimum nailing pattern and stud spacing for various wind speeds. But for this table, this footnote will tell you if you've got wall studs that are 16 inches on center, you're going to have the gypsum board on the interior of the wall, wood structural panel that can be that minimum 3/8 inch thickness on the exterior with the minimum 8D nails at 6 inches on center, along panel inches, and 12 inches on center at supports. And you're going to have blocking behind those panel joints. The second footnote deals with when you have wind speeds that are higher than that 115, which is the center of the country area. And when winds are higher than that, you're going to actually have a connector that's attaching the studs up to the top plate and down to the bottom plate with a minimum 300-pound lateral capacity, which is new, something we haven't had a requirement for, and is occurring because we have these taller studs. Maximum spans are noted as simply applying to either single or multi-span roof and floor conditions. And there's a note that the roof assembly may not contain a habitable attic. So again, they're just limiting how much gravity load is within this building. And where will the loads be going in the load path? So the next section in our walls that is a very large change, actually is probably the biggest change in the 2018 IRC for wood construction and the building frame, happens to be our girder spans and header spans. Now, Michelle already mentioned that this table is reducing the spans of the members, and so we've got header spans that may have dropped up to a foot again. And that's a concern simply because we had a drop in span length in the 2015, and we, in some cases, have a drop again here. This table also changes in other ways. The building width has changed. It used to be based on a 20, 28, and 36 foot building width because initially this table was back in Chapter 5 floors, moved to Chapter 6 walls, but maintained the same building widths. So with the 2018, we dropped the building width down to 12, 24, or 36, which can be helpful with some of the headers in walls. We continue to have both the span listed and the number of jack studs that are required. Typically, it's either 1 or 2. Occasionally, there's actually 3 jack studs required at the end of the header. The IRC also has the same footnote for a dropped header. For example, when you're at the front of a garage and the garage door is only 7 or 8 feet tall, typically the construction will drop a header onto that and then put studs up above it. That's all good, but with the 2018 code, we're going to have to actually reduce the capacity of that header by 30%. So multiply that 0.7 factor to each span length and reduce it to a shorter span. So there will be reduction in header lengths again, and perhaps that will drive at least the longer spans to using a manufactured lumber similar to what we already see at the front of garages. So you may see more LVLs occurring in some places. The interior bearing wall table also changed, same changes. we have the 12 24-foot spans. The tables are driven by a number 2 southern pine or number 2 hemlock fir as the weakest of the lumber for a header application. Okay, so we're back to the next polling question, and Marcy.
Absolutely. So what is the difference between rim board and 2x headers? So rim board is a 2x stick of lumber. Rim board tends to be 2-inch nominal in thickness. Rim board is a manufacturer's name. And what is rim board? All right. So sorry, 2x. And I've got about 67% in 40 seconds. I'm going to close. And we've got 67% say rim board tends to be less than 2-inch nominal in thickness. 20% say rim board is 2x stick of lumber. 9% rim board is manufacturer's name, and 4% what is rim board. All right, and Sandra, what is the real answer?
So the answer here is that rim board, a manufactured rim board, is less than 2-inch nominal in thickness. And the reason I actually asked the question is because this term gets used differently across the country. So manufacturers of structural composite lumber use rim board as the term for a material that is thinner than the rest of their products that works just fine to block joists or to be that framing member on the exterior of the joist within a floor. But at the same time, there are areas of the country that are still using solid sawn lumber, and so they may very well use the term rim board to be, again, that rim around their solid sawn joists, and they actually could have a 2-inch nominal one. So even my answer isn't the typical language across the country, and that's just something to be aware of, that the term rim board really does change in many areas. So as far as our change to this section of the IRC, it's actually a very small change. And in fact, if you look at the figure, it's changes to the figure here where we have a new hanger and then some new comments as far as what is going on with this wall. So the point here is that with rim board, when you lap it, you've got a thickness that is too thick to have sufficient bearing left for the joist, and you're going to have those joist hangers. So anytime they're lapping the rim board by making a 2-ply rim board, you should see joist hangers on the other side. If they're splicing it with a metal connector and only have a single ply, then it's not going to be a problem if they have floor joists resting on that. Now this is going to be true for 2x4 construction too. If you go to 2x6 construction, lapping of that rim board is likely to still give you the bearing length that you need to just put the joist on top. And that's something that isn't completely clear within the IRC at this point. Another new note, we've got the rim board header, end or splice extending 6 inches past the outer full height stud. And that's outer full height stud of the opening. So the king studs are going to be there. You want to make sure that that rim board header for a splice is going to extend beyond it when you're using rim board as a header. All right, the next table, and I kind of take a deep breath with this one because the 2015 IRC was the first time we saw this table, and people kind of panicked with it. It talked about the number of full height studs you should have at the end of a header in exterior walls, with the idea that when you put in a window or a garage door, you are taking out a number of headers that are there for out of plane support of the wall due to wind loads. And the initial table looked at stud spacing of 16 inches and 24 inches. This table assumes that you have a stud spacing of 24 inches, and it's looking at how many studs should you have at the end of that opening and at the end of your header to brace the header, brace the wall due to out-of-plane wind loads and for gravity loads. Well, it depends upon your header length. If your header span is short, you just need that one king stud at the end of the header, unless you're in higher wind regions. And then quickly you need more than one stud. Notice also that this is broken down by wind exposure category. So 115 miles per hour wind exposure category B, for an 8-foot header span, I just need one king stud on either end of that header. But if I'm in 130 miles per hour or less and exposure category C, so that's basically 115 or 110 miles per hour exposure category C, now for an 8-foot span, I need 2 king studs at each end of that header. So that's the intent, is just to stiffen up the wall by adding some more king studs as needed for those longer spans. When we look at the larger garage spans, that's where you see a lot of studs at the ends of those headers, and especially in high wind regions. The next change is actually in the wall bracing section and is a very minor change. We have finally reached the point where wall bracing is not changing hugely every code cycle, and in fact in the 15 and 18 there were just small clarifications. This one, for item number 5, roof and ceiling dead loads for walls that are supporting some number of stories. At one point, back in say 2009, if you looked at the IRC, it was clear that when you looked at the top of a 2- or 3-story building, you needed to have more bracing added that story when you had a heavy roof. So a concrete tile roof, clay tile roof would create more weight on the roof. And remember, we're looking at seismic adjustment factors. So we're looking at where a large earthquake is possible. And when a building is heavier, the seismic load to that building is greater. So by adding a heavy roof, we need to add wall bracing to deal with that greater weight. So at the top story, we add 20% extra bracing, that 1.2 factor. At a second or a third story lower down, we only add 10% to the amount of bracing that's on the wall. And when a roofing material is less than 15 PSF, which are our typical asphalt roofs, then we don't add any additional bracing at all. It's just when you have a heavier roofing material. So that was a clarification there. For the frequent case that we have growing across the country where somebody wants to add a brick veneer or a stone veneer to the front of the house, and the other 3 sides of the house are not decorated with this additional veneer. We've had within the code a brick veneer with wood structural panel special type of bracing that was only used in high seismic regions. Well, it requires hold downs at every single braced wall panel, and therefore ends up requiring a lot of hold downs. They're not only at the bottom story, they are at every story within the building and carried all the way down to the foundation. So it's a lot of extra straps. And there was a desire, when you just have that brick veneer on the front of the building, to have a more simple solution. So our solution now is that if a building has brick veneer only at the first story and doesn't extend up into the second story, then there is no increase for bracing. If that brick veneer moves all the way into the second story, then you have 2 options. You can use the wood structural panel with brick veneer wall bracing option, or you can use your typical wood structural panel or continuous sheathing wood structural panel and just increase the amount of bracing by 20%. And that 20% is going to go on the wall that has the brick veneer, and any perpendicular brace wall lines that run into it. So the exterior side walls, and if you have any interior braced wall lines that are running front to back in the building, then extra bracing would go on those as well. Now, unfortunately, since we don't have anything about increasing the amount of bracing on method gypsum board, those interior brace wall lines are going to end up being wood structural panel or continuous sheathing wood structural panel. But in high seismic regions, we're always seeing that have to happen when you're choosing to use the IRC and the wall bracing section. So that was the change there. The last addition is just a clarification again that when there is no horizontal blocking on any story, that the amount of bracing that must be increased is to actually double the amount of bracing. And this is only allowed with wood structural panel and continuous sheathing wood structural panel. This was actually an exception back in section 602.10.10. So we're moving it out of that exception into the seismic adjustment factors area, just to make it more obvious that it's there. Occasionally somebody has a single family home where those sidewalls are very short and they just don't want to deal with the blocking. They've got a 10-foot tall wall, all their panels are 4x8s, and so they can choose to have on these sidewalls where there are a few windows just twice as much, and it works fine. Our next change is just changing out what are available fasteners. So with the method structural fiberboard, the fasteners are typically shorter than your 8D common nails, and so we have the 8D common nails deleted, and we've just got the 1 3/4 inch by 0.12 inch diameter nails for your thicker sheathing, and the 1 1/2 inch by 0.12 diameter nails for the 1/2 inch structural fiberboard sheathing. So just a clarification here. Not that you can't always use longer nails. All right, moving on to bearing. So now we're in chapter 5, floors, and this is just a clarification where joists with insufficient bearing on concrete or masonry can use a joist hanger. So there are joist hangers out there available for wood that are being used all the time. So here we're just clarifying that, yeah, even if your wall is concrete or masonry, you can use those joist hangers. The next section of framing is Chapter 8 on roofs, and here what has happened is we have reorganization of the entire section. So the section used to have mostly ceiling joists addressed first, rafters later, but everything was sort of mixed together as changes had occurred in this section over various code cycles since the 2000 IRC. So now it's reorganized, divided up into a section on design and construction that's basically saying the roof and ceiling assembly will have continuous ties across the structure, and you're going to prevent roof thrusts from being applied to the supporting walls. Then we've got the ridge section that is addressing using a ridge board versus a ridge beam, and that's one where people still get a bit confused. But ridge beams are going to have to be engineered, and you can then cut your tributary area down to, instead of exterior wall to exterior wall, that exterior wall to ridge beam, which, since the IRC is based on not using engineering, has been less than clear to everybody. But with just that 1 inch ridge board there, their span is all the way across from exterior wall to exterior wall, and that is clarified. The next section is now addressing rafters. So we have a subsection of rafter size, of framing details, of information on hips and valleys, on the rafter supports, on purlins, and then on collar ties. And so that information has been pulled from many different sections and all put together. Ceiling joists have a section on ceiling joist size, then the joist and rafter connection, where and how to actually lap the joists, the rafter ties, and blocking. And again, this information was mixed in with the information for the rafters before. So it just makes everything easier to find and easier to tell what's actually addressing a rafter versus a ceiling joist. Another clarification was just how far can the roof sheathing be lapped beyond the exterior wall before you have to extend the framing to support it. So you can cut framing off at the exterior wall and allow the roof sheathing to extend up to 9 inches beyond that end wall. But once you go beyond that 9 inches, you have to have the framing extend with the roof sheathing. So your typical soffit being 2 feet, then you've got to have framing going out that 2 feet to support the roof sheathing on top. And this one actually addresses specifically gable end walls and gable overhang framing, in part because a gable wall is assumed to only carry its own weight and not have the roof framing putting a load on that wall. So once you start to extend the framing and the sheathing out, now you have a load on top. Soffits typically were not wood structural panel in the past in the IRC, so we now have the addition of an option of using a wood structural panel with, same as the walls, that minimum 3/8 inch thick sheathing allowed, fastened to the framing or nailing strips with a 2 inch by 0.099 inch nail, and the nailing patterns being the same as the roof sheathing and the wall sheathing. So you're looking at 6 inches on center, 12 inches on center at intermediate supports. And this is being driven in part by the fact the wall bracing section has a requirement that you brace your wall bracing and braced wall panels all the way up to the roof sheathing, which in some cases means that people choose to add blocking at the top of the wall and then put wood structural panel out along their soffit. So here in Chapter 7, we have recognition that you might have that wood structural panel in the soffit areas. This next section is new and interesting. Here we have recognition that some vinyl siding has been tested to the point where it may be attached to wood structural panel over foam plastic sheathing and not be attached to studs themselves, but just nailed into the sheathing. So that was kind of a change that we saw coming in with the 18 codes, is some instances where vinyl sheathing could meet the testing requirements and meet these very high wind pressures, then it could be allowed to simply be nailed more frequently into the wall sheathing and not have to be nailed specifically into the studs behind it. So just trying to allow yet another opportunity to install things without looking for where the studs are. This isn't an easy thing for the vinyl siding manufacturers to do as far as these higher wind loads are concerned. They're having to meet the wind loads by saying that the siding will remain on those walls without that extra resistance of going into the studs. But it's here as an option now. And notice in the footnotes that footnote D has for the indicated wind speed condition, foam sheathing only on the exterior frame of walls with vinyl siding is not allowed unless the vinyl siding complies with an adjusted minimum design wind pressure requirement, which is in the table. And the wall assembly is capable of resisting an impact without puncture of at least the equivalent of that of a wood frame wall with minimum 7/16" OSB sheathing. So literally trying to make sure that whatever you do with this wall, it's going to be equivalent to what we're accustomed to. Moving on to fire resistance. So here we're back in Chapter 3 of the IRC, and we've moved away from the framing of the building to, all right, how do you protect buildings? How do you protect them on interior walls when it happens to be a duplex, a triplex, or a townhome? And how do you protect the exterior? So with the IRC, we rely more on the IZC, the International Zoning Code, to deal with the exteriors and lot lines, just like we do with the IBC. But in some areas of the country, the zoning code is not adopted, and there's either local zoning requirements or they're actually using the IRC and the IBC to do those limits. So what we have within the IRC is a statement that you're going to protect the exterior walls if the building is from 0 feet from the lot line up to 5 feet. Once you reach 5 feet, you don't need to protect the exterior walls. Projections, since we have soffits that project out, we have decks and balconies that project out. Here we've got a requirement that you can't put them within 2 feet of the lot line. When they're 2 to 5 feet of the lot line, you need to have 1 hour rating on the underside of that projection, and it's typically a roof soffit that you're looking at. Or you can use heavy timber, or you can use fire retardant treated wood. There are also a couple of footnotes for this item that allow you to take some roof sheathing up into the roof above the exterior wall and basically protect everywhere from the wall inwards and allow that out to exterior area to be a sacrificial area. If you're up to 5 feet away from the lot line, then no fire resistance rating is required at all. Openings are similar, although their limits are at 3 feet rather than the 2 feet and 5 feet. And you're basically not allowed to have an opening in the wall if the wall is less than 3 feet from the lot line. When you have 25% of the wall with openings or less, then you need to be at least 3 feet from that lot line. If you get out to 5 feet from the lot line, then you have an unlimited number of openings that are allowed. And again, with zoning codes, typically you can't get closer than 5 feet from the lot line. So this only really occurs in an area where you don't have a zoning code or there are some special zoning provisions allowing you to be closer. Lastly, penetrations. If they are within 3 feet of the lot line, then you're going to need to protect them. If they're more than 3 feet from the lot line, then they're fine without any additional fire protection. Townhouse separations, the last 3 code cycles, this keeps getting tweaked again and again, and really the intent has just been to try to clarify what can you do. And we started off with the code stating that you needed to have 2 separate 1 hour walls, but then there was an exception saying you could have a common wall. Then the code moved to stating you could have a common wall, or as an exception, you could have 2 1 hour walls. And at this point, the code's really just trying to say you can do any of them. You can have 2 separated 1 hour walls. You can have, if there's sprinklers in both of the townhouses or that are connected to one another, you can have a 1 hour wall. If there are no sprinklers, which is most of the country currently, you have to have a 2 hour wall. Or you can do any kind of alternate assembly with any kind of shaft liner in there that is going to deaden sound, which is the interest typically in townhouses, is just stopping sound from transmitting from one side of the wall to the other. So do whatever you want. It just needs to be equivalent to either the 2 1-hour walls or the 2-hour common wall. Any and all of those options are fine. And this really comes up because across the country, nobody is building these walls the same. It is very unique to each region as far as just how they do this. And so we have been striving for clarity within this section for multiple years now, and hopefully we've actually reached it. Oops, wrong way. All right, the next fire protection item, this one has been growing. So this one is a very interesting change in that its intent was to allow firefighters to be safe when coming in to rescue people. So all the other provisions in the IRC are based on safety of the people who reside in that home. And this one is rather safety of people coming in and also an extended amount of time that people would be able to get out has been the intent. So what it is saying that if you don't have solid sawn lumber joists in a floor and there's a space beneath that floor, so it might be a basement and it might be a crawl space, you're going to protect that space underneath by either putting in the 1.5-inch gypsum board. And this isn't a 1-hour rated wall. All you're doing is screwing in the gypsum board. That's it. No taping, no finishing. And that's coming because we have groups of people who say, hey, we want to leave an open space for people to finish out later. It makes the cost of the house a little less for them. They get to do what they want. And yet we also have the group saying, hey, this isn't as safe if is not an enclosed space. So the compromise there is the 1.5-inch gypsum board. Anytime you have wood trusses that aren't fire retardant protected in some way in that space or tested to be equivalent to solid sawn lumber, any sort of I-joist or thinner than 2-inch wide composite member that's going in there that hasn't been tested or isn't fire retardant protected. So a lot of the country we have I-joists and we have trusses as part of our floors. Those areas, if you have a crawl space that has your furnace, water heater, etc. in that space, you're going to do this 1/2-inch gypsum board protection or something equivalent. If there's a basement, you're going to do this. And there are a couple exceptions to get around that. Well, the change in 2018 was to say, all right, before these were fuel-fired appliances, so gas-fired or propane-fired typically across the country. Now if they're electrical appliances, they're also going to require installation of this 1/2-inch gypsum board. So it no longer really matters what fuel source or process to run this equipment it is. If it's in the basement, if it's in the crawl space, that 1/2-inch gypsum board is going to need to be added or something equivalent to it. All right, our final section, which has been growing every code cycle, happens to be decks. So we're going to talk about decks next, but first, Marcy is going to do the final, I believe, almost final, polling question.
Absolutely. All right, and it's another one of the familiarity questions of, are you familiar with the DCA 6, AWC's Deck Construction Guide? Let us know if you use it periodically, if you've looked through its requirements, you think you thumbed through it once, or nope, what is that? So it looks like so far it's a little scattered or a little more evenly mixed what your familiarity is with this. So I've got about 75% have voted in 37 seconds. So since we're running a little low on time, I'm going to go ahead and close it. want to leave some time for questions at the end here. So 40% have not heard of our DCA 6 deck guide. 27% think they've thumbed through it once. 18% have looked through its requirements, and 15% use it periodically. So that's great. Back to you, Sandra.
Okay, so that was simply a curiosity question there of how many people were familiar with it, because many of the provisions that are within the deck section of the IRC have come from this document. And as we look at them, you'll see that this section changed quite a bit again. A lot of it was reorganization, but some of it was adding information that's helpful for that deck, whether it's a deck in new construction or a deck with an existing building. And the IRC doesn't often address existing buildings, but it does here. So if we look at the new sections, and the table you see just helps you figure out where it was before and where it is now. But there's a brief statement about decks in section 507.1. Then we get to topics of the materials of the deck, protection of those materials. Then we go on to a section on footings, and we start to literally build the deck up from the ground. So footings comes first in section 507.6. Then we look at posts, then at beams, at joists, at decking itself. And then in sections 507.8 and 9, we kind of look at how do you support this deck for lateral loads. So that's where we start to see those lateral connections show up in the requirements here. So we'll look at this in more detail. Starting with deck materials, previously there was information on plastic composites. Now we actually have information on wood materials. That same information that existed before is brought over for the plastic composites. We also have information on fasteners and flashing now within this section. In a new table, we have more detail than we ever had before on fasteners and connections. And these fasteners are very similar to the fasteners that we see in Chapter 6 in Section 602.3, except here, these are fasteners that are going to need to be outside all the time, and so we start to see that they need that thicker, hot-dipped galvanizing with the zinc coating, or they can be stainless steel, or silicon bronze, or copper. For the bolts, lag screws, we have different standards telling how they need to be made, but again, sort of the same requirements. They're going to need to be hot dipped, or with the bigger diameter fasteners here, you do have an allowance to be mechanically galvanized, which gives you a thinner layer of zinc. They can be stainless steel, they can be silicon bronze, or they can be copper. With metal connectors, so we're talking all the different kinds of connectors that you have available on the market right now. Manufacturer specifications are what we're going to go back to, and there we're looking at something that has been hot dipped or is stainless steel, and stainless steel connectors are actually on the market in some cases now. So that's kind of our difference between our framing connectors that we see for the interior of the building and these connectors that we need at the exterior of the building in a deck. Minimum footing sizes. We actually have a table now addressing how big does that footing need to be. It is based on the load-bearing values of soils. So if you have poor soils in your area, you're going to be looking at that 1,500 pounds per square foot. It's also based on what a ground snow load is in the area, or if there's just a live load, you're in the southern half of the country. You have the tributary area of the deck coming down to that post and footing. And then it's assuming either a square footing or a round footing, because again, across the country, it varies a lot as far as what footing shape people are using. And lastly, it gives you a minimum thickness for that footing. So we now have the dimensions of a footing that you would need for a deck. And this diagram only changed slightly within the 2018 code, and it's again looking at what kinds of different footings do we have across the country. As you look at it, probably in the area that you happen to be from, you'll see one or two types that are typical for your area, but we have huge differences within the country. And therefore, we're just giving a little more information, a little more detail here on what that might look like. If you look on the far right, we have the pressure-treated post that goes all the way down to gravel at the bottom. So this is the major change here, and it's simply showing that you're going to have gravel under that footing to support the pressure-treated post and the concrete footing that's going to surround that post. The connectors have also been added in some of these other details. All right, so post height, as we go from the footing up to the posts, changes here were some clarification. So 8x8 post was added because we had people saying, hey, you know, if you're going to notch the post, we could use an 8x8 in the table. So it was added in. The statement that the load that is assumed for these decks is 40 PSF still. So that's in there as new footnote B. And then the maximum permitted height of 8 feet is for 1 or 2 ply beams only, and that's just because, again, if you're going to notch your post, you have very limited space, and when you're looking at a 4x4 post, there is nowhere to notch it. So we're capping off the height there at 6 feet 9 inches. And as it says, the maximum permitted height for 3 ply beams that are going to be on top of a post cap, so there's some way to connect them to that post below, is going to be the 6 feet 9 inches. The 1 and 2 ply beams, they can have a height of up to 8 feet. And we're just looking there at what's the maximum amount of beam that you can attach physically to that post. What capacity does it have? With beam span lengths, we have 1 ply beams that have been added. Of course, the deck joist spans are very small, but for little corners of the deck that have separate spans, they're going to work just fine. And we have clarification that a beam's cantilever is limited to the adjacent beam's span divided by 4. So this was in the text before. This is actually moving to the table where you might expect to see information about what that beam should look like. So beam span, we have a cantilever of 4 feet. As we look at joist necks, we're going to see that the joist span, the joist cantilever span has some additional subtlety to it as we get there. All right, we also have some updated sketches, and in this particular sketch, if you happen to be looking in the significant changes book, for whatever reason, they actually added a different attachment to the post, and so you see a bolt going into the splice where it should, or a lag screw going in the splice where it shouldn't, and that's going to be an errata in the book. But we do have the new image of a notched post with that beam coming in there. We also have some new images just showing a bolted connection and what that would look like, whether you have a splice there or not. For the joists, there's now a column that deals with the allowable joist span, and then a maximum cantilever column as well, dealing with how long can that cantilever be for, say, a Southern Pine 2x8 joist, 16 inches on center. In this case, that would be a 2 foot 3 inch long span for the cantilever beyond the main span. We have updated a slightly updated cantilever joists. We have some cantilever joists that show the drop beam and flush beam, and then we also have some freestanding sketches now showing what a freestanding deck would look like with that dropped and flush beam. There's a section that says alternate ledger details. The intent here is to say that, you know, we have called out within the IRC one type of ledger connection, but you can do whatever alternate you want, and this just clarifies that the alternates are fine. As long as they're equivalent in strength, they're good to go. Lastly, I just wanted to bring up, for those who didn't see the 2015 IRC, we have a lateral load attachment second option that came into the code, because the one that was in there in the 2012, 2009 was difficult to install in an existing building. So this newer lateral connection, rather than having ties that go into the floor joists on the interior, actually connects from this angle through lag bolts into the top plates of the story below. And in some cases, decks line up beautifully to do that. In other cases, they don't, but it is an option that is within the code now. All right, moving out of decks and into the final few sections. Structural insulated panels do have an updated reference, which has caused text that was in the IRC about how to manufacture the panels to simply be referenced in the APA document PRS 610. So you will no longer find that language in the IRC, and it was only addressing manufacturers, not the design of the building. The building thermal envelope now references directly the ICC 400, so as you're looking at the thermal envelope, you no longer have to meet those requirements for a log home if that log home is built to ICC 400. That's just to ease up use of these requirements for the log homes. And lastly, tiny houses is now an appendix in the IRC. That is looking, tiny houses by definition are less than 400 square feet, and they can have a loft, and you can have a ladder up to that loft within this appendix. All right, as far as resources, there will be in Structure Magazine in the March issue an article on the IRC. So just as we already mentioned, the 2018 IBC and IEBC changes are out. There will be a similar companion article for the IRC. And it will also have an appendix that you can look at to see where changes occurred within the code hearings. And we have the significant changes to the International Residential Code available as well through ICC, if that is something that you find useful. Lastly is the final polling question with Marcy.
All right, and this is just a very, very quick, short little survey that we're using for some of our data here. We are trying to develop some programs. If you could just let us know if you have taken a wood design course in college. So yes or no, real quick. And I've noticed 69% in 20 seconds. I'm just going to let it go here for another 5 seconds, and then we're going to close out. There we go, 30 seconds, quick. All right, so 53% no, 47% yes, so almost split down the middle. So thank you very much for your answers there. Do you have a little bit more, Sandra, or should I go ahead into my housekeeping?
I am done.
Okay, so let me take the screen here. All right, so thank you so much, Sandra, Michelle, and Jim. I have just some quick information for everyone. Please note that Brian is going to post today's survey in the chat box. We're going to do this just a little bit differently. You're also going to get it in the email that's going to be sent shortly afterward, but you can take a quick minute now to fill it out for us as I'm finishing up, or you can just wait until you get it in your email. Our partner organization, Woodworks, provides wood project assistance and other resources. If you want to reach out to them, email help@woodworks.org or visit their website at woodworks.org. You can also request assistance from them on that survey that we're sending out. or that is in the chat box. All right. Our design professional membership helps people stay informed about technical issues affecting the wood industry. AWC has this membership that's available with lots of benefits, including discounts on our publications. Check out www.awc.org/membership if you're interested. Our Code Official Connections benefits, we offer this special program for qualifying code officials. There are also benefits associated with this program, very similar but a little bit different as well. Go ahead and check us out at awc.org/codeconnections. And then remember, there will be a follow-up email for this. If you haven't already done so, complete the survey for a chance to win a free publication. The survey link that you receive in the email is the same survey that's being posted in the chat box at the end of today's presentation. Check out the information about your certificate of completion and CEUs. Note that the actual certificates will not be available today. They're going to be available within 2 weeks. Remember that in order to receive credit, you must have been present for 90% of this 2-hour webinar. And then please join us again on March 8th for the first webinar in our Tall Wood series, Fire Tests. And then the following webinars, Adhesives and Code Changes, will be on March 16th and April 5th, respectively. If you have any other questions or want more information, just email us at education@awc.org or visit us at www.awc.org. Thank you once again for your attention and survey feedback. And now back to Sandra, Michelle, and Jim for some question and answers. And I just went blank and I apologize. Michelle, I'm giving it back to you, right?
So Michelle, I think you're still muted. I'm gonna ask Sandra if you would to unmute, and maybe one of you go back to slide 70 and 72. That's where we'll start with our Q&A, and maybe
Michelle, I gave the screen to you.
I gave it to Sandra.
Oh, sorry.
Yeah, I have it
there
now.
we go. All right, excellent. So
this crazy section.
We are on the wind table. So what happens if you're in exposure C? This table applies for exposure B, as I understand the footnotes.
Yeah, for the 2018 code, you are still stuck doing engineering, even if you're in 20 PSF snow loads, but you're in wind exposure category C. And that's engineering just for the gravity and the out-of-plane loads, not for the wall bracing, because we have prescriptive requirements for the wall bracing. And I know that sounds crazy.
The other option, too, is a reference to AWC's wood frame construction manual. So I'll give a shameless plug for that because it has a lot of tools that will help designers with higher wind speeds and exposure categories all the way up to exposure D. Now let's jump to slide 72 if we can.
Okay.
And I see it says that on the slide, but there was a question about clarifying between ground snow load versus roof snow load.
Yeah, that comes up a lot. Okay, so for the building departments, the ground snow load is that snow load that you're reading off the snow maps, and that's the one that all the sections of the IRC now reference. At one point, the IRC referenced both roof and ground snow loads just to make it a little more confusing. So now everything has gone to ground.
Okay, excellent. Next series of questions had to do with the revision in R302.13, slide 87. And yes, we know this comes up a lot too. So if you could just clarify, if you're over a crawl space and there is no heating equipment, is this still required?
Yeah. If you're over a crawl space and there is nothing that's been put in that crawl space, then don't worry about this.
Right. And then the other question is, what about an aggregate area where this might be required? Would it need to be for the entire room, lower story, or just a certain area?
There are a couple ways you could look at that. If you have it in a space, and I may get the square footage wrong, but I believe it's an 80 square foot space, so sort of a mechanical closet. If you have that space, then you don't have to do this. So there's an exception for that. And basically the assumption there is it's an enclosed space, and so the fire won't extend as fast beyond that space. We really don't have anything else right now. If you had multiple rooms within a basement, could you just have one room have the mechanical equipment and not do this to the rest? So that's not addressed.
So I'm looking at the provisions in the code, and you're not able to add all the footnotes, obviously, to a slide. Mm-hmm. So it does deal with that 80 square foot area, and then some fire blocking requirements that would be along the perimeter that would mm-hmm. sort of cordon off that space, I think, is probably mm-hmm. the way to look at it. All right, so this one can go to either Michelle or Sandra. This has to do with carriage bolts. So we have provisions for decks and a certain type of bolt that's prescribed by the NDS or even the DCA6 document. What about carriage bolts? And if that's a, if I'm throwing you a curveball there, I can take that one as well.
Michelle, did you want to do it?
Oh, I was going to let Buddy do it. He okay. seems to be prepared for this.
I got it. Okay.
I'm sorry, I was trying to answer something else.
No worries. We get that question a lot, and because of the carriage bolts are fully threaded and not yet covered under the ANSI standards that we refer to in the NDS, the prescriptive provisions that we develop in DCA 6 would not necessarily cover carriage bolts. However, if a designer were to, or a code official were to look at the provisions that govern carriage bolts and determine that there is an equivalency there, then we certainly don't prohibit those alternate materials. But I guess the answer is they're not specifically permitted or called out in the document, but also not specifically prohibited. So how's that for a weasel answer? All right, so I think we have time for one more, and I'm going to ask you, Sandra, to once again clarify the deck loading provisions, because we talk about residential decks here in the IRC, and folks are wondering if we apply that 1.5 factor to residential decks.
Yeah, this time you do not apply the 1.5 factor for residential decks. It's the IRC table 301.6 is the live load requirements, and it continues to have 40 PSF for decks in that table.
So the 1.5 times requirement only applies to decks that are covered by the IBC. That's where that specific requirement comes into play, not for decks covered by the IRC. So that got asked multiple times. We want to make sure that we wanted to cover that.
And as an engineer, feel free to increase the load on that deck. There is nothing that says you can't do that. This is just a minimum 40 PSF.
Correct. But if, homeowners, builders are looking for what the minimum requirement is, it's 40. We can certainly always go above code. That is correct. All right. Well, we are almost a quarter past the hour, so I think we're going to wrap up there. Thank you both for an excellent presentation, and we will see you all next month, hopefully, at our next series of webinars. Have a great day.